Welcome everyone to Webinar Wednesday with the Saskatchewan Construction Safety Association. My name is Justin Brooks. I'm a safety advisor. I help companies here in Regina, as well as my assigned regions, which are Yorkton and Esterhazy. So just before we begin, this webinar is currently being recorded for later viewing. Will be posted to Facebook, as well as our YouTube channel. Find us on YouTube, type in SCSA in the search bar. Hit that little red subscribe button to stay up to date on all our toolbox talks, which include topics like social distancing, mental health and stigma, hot weather and hydration, and our Wednesday webinar videos on topics like harassment in the workplace, women's framing, and many more. If you're not following us on social media, after the video, look us up on Facebook, Instagram, everything. Hit the like button to keep up to date on all things safety in Saskatchewan. So before we roll into our presentation, I just want to take a moment to let everyone introduce themselves and talk about their regions and what they do. So let's start in my screen to my left. Let's start with Joanne.
Hi, my name is Joanne Davis and I work out of the Regina office. So I also help out companies and members out in the Swift Current area as well as Moose Jaw.
My name's Kieran Greening. I work out of the Saskatoon office. I help companies all around out east of Saskatoon towards Humboldt, out west towards Macklin and the greater Saskatoon area, as well as Prince Albert.
I'm Kara Bildfeld, safety advisor at the Saskatoon office, and I also handle Milford, Nipawin, and Tisdale.
Perfect. And just so that everybody's aware, which if there are a few that aren't, these aren't all our advisors. We actually, there's a lot of us, and we tend to all areas within Saskatchewan. So these are just a few of us here in the areas that we look after. So without further ado, I think that's French, right, Joanne? Perfect. I'm learning. We're going to talk about excavating and trenching. So I have a PowerPoint put together here, which I will once again share my screen, and I have to remember to share with audio because we have some video in here. Yeah, we're good. Awesome. We are live. So excavating and trenching. So on we go. Come on. All right. So first, we're going to review common causes of accidents involving excavations and trenching, as well as regulations pertaining to excavating and trench work. Excavating and trenching fatalities are mainly caused by cave-ins. Death occurs by suffocation or crushing when a worker is buried by falling soil. Working around excavations and trenches can be highly hazardous without the proper training or controls in place. Main causes of lost time injuries on excavating and trenching projects include material falling into the excavation or trench, slips and falls as workers climb on and off equipment, unloading pipe, handling and placing frames and covers for manholes and catch basins, handling and placing pipe and other materials, being struck by moving equipment, falls as workers climb in and out of an excavation or trench, falling over equipment or excavated material, falling into the excavation or trench, exposure to toxic, irritating, or flammable gases. So when working around an excavation and trenching, it's very important to plan ahead, always be alert, and to take extra precautions to avoid being faced with one of these situations. When working around excavations and trenches, it's important that you become familiar with the parts of the Act and regulations: excavations, trench, tunnels, and excavated shafts. Before moving on, let's look at the definitions for excavations and trenches. I'm having a hard time with that word for some reason. An excavation is any dugout area of ground other than a trench, tunnel, or excavated shaft. Working around excavations can be risky as it could result in cave-ins. A trench is an excavation that is deeper than it is wide, and a tunnel is an underground passage with an incline of 45 degrees or less from the horizontal. Other important regulations you should be familiar with include Section 260, excavations and trenches. This identifies the various types of protection around excavations and trenches. Some forms of protection include shoring, sloping, temporary protective structures, etc. The OHS division shall be notified as soon as reasonably possible of the intent to dig an excavation, trench, or excavated shaft that is more than 5 meters deep, and that a worker will be required or permitted to enter. That's in Section 7(1)(b). Legislation states that an engineering certificate is required when excavating or trenching using shoring, bracing, and temporary protective structures. It's in Section 261. Prior to any excavation or trenching, a safe job procedure must be developed and implemented, as all workers must be trained. This is in section 19. And actually, we'll go over this at the very end, but I do believe our next toolbox talk is on developing procedures. So if you're having trouble with that, obviously contact advisory services, but also tune into that toolbox talk. Protection against cave-in trenches, subsection 5, indicates where a worker is working in a trench more than 1.2 meters deep, a competent worker must be stationed at the surface to alert the worker in the trench about the development of potential unsafe conditions to provide assistance in the event of an emergency. This is in section 263. So let's go over the cause of cave-ins. A cave-in is a collapse of an excavation. When working around excavations and trenches, one of the biggest hazards is risk of cave-ins. An unstable trench or excavation can collapse, resulting in injured workers or worst case fatalities, caused by suffocation or worker being crushed when buried by soil. To put this into perspective, 1 cubic yard can weigh as much as a half-ton truck, approximately 2,500 to 4,000 pounds. Soil properties often vary from the top to the bottom and along the length of the trench. Many factors such as cracks, water, vibration, weather, and previous excavations can affect trench stability, potentially leading to cave-ins. Traffic and equipment working around this excavation or trench can also lead to cave-ins. Most fatal cave-ins occur on small jobs of short duration, such as service connections and excavations for drains and wells. Too often, people think that these jobs are not hazardous enough to require safeguards against a collapse. Unless the walls are solid rock, never enter a trench deeper than 1.2 meters, 4 feet, if it is not properly sloped, shored, or protected by a trench box. Time is also a critical factor when working with excavations and trenches. Some trenches will remain open for a long period, and suddenly collapse for no apparent reason. This figure shows the typical cause of cave-ins. So things to ask is main factors that affect excavation and trench stability are soil type, moisture, vibration, surcharge, previous excavation, existing water, existing foundations, and the weather. Before considering excavating and trenching, you should consider the soil type. Type of soil determines the strength and stability of trench walls. Identifying soil types requires knowledge, skill, and experience. In other words, a competent person shall be responsible for inspecting and identifying the soil. This is important because even hard soil may contain faults in seams or layers and make it unstable when excavated. Types of soils are defined under Regulation 257, Section E, F, G, and H, which we will cover shortly. Supervisors should be aware of the soil types which may be encountered during a job and plan protection accordingly. The moisture content in soil can have a great effect on the strength of the soil. Once a trench is dug, the sides of the open excavations are exposed to the air. Moisture content of soil begins to change almost immediately, and the strength of the walls may be affected. The longer the excavation is exposed to the air, the greater the risk of cave-ins. Vibration from various sources can affect excavation and trench stability. Often, excavation and trench walls are subject to vibration from vehicular traffic from construction operations such as earth moving, compaction, pile driving, and blasting. These can all contribute to the collapse of trench walls. And a side note, for anybody that's been around heavy track vehicles, pieces of equipment, like excavators, you can feel the vibration in the ground. So that vibration is obviously moving through these trenches and can definitely, without a doubt, cause collapses. A surcharge is an excessive load or weight that can affect the stability of an excavation trench. For instance, excavated soil piled next to the trench can exert pressure on the walls. Therefore, placement of spoil piles is very important. Spoil piles should be kept as far as practical away from the edge excavation or trench. Mobile equipment and other materials stored close to the trench also add a surcharge that will affect trench stability. Spoil pile is defined by Section 257C of the regs, which is stated, a spoil pile is material excavated from an excavation, trench, tunnel, or excavated shaft. This actually brings an important thing to mind that even when they're doing setting the rings for catch basins and things, some companies have used skid steers. Skid steers get too close to the trench. So it's important to plan ahead for the type of equipment you use, like, for example, a telehandler or a zoom boom that can actually bring those rings and drop them over the trench from a distance. In accordance with regulation section 260C, spoil piles should be kept at minimum 1 meter, 3 feet from the edge of an excavation or trench. This also applies to equipment, rocks, and construction material. This distance should be greater for deeper trenches. So cave-ins are caused by a combination of soil content and environmental factors, including vibration, weather, previous excavation. 1 cubic meter of soil is equivalent to 4,000 pounds. So that's a good thing to kind of remember and keep in the memory bank of how much this weighs. Spoil piles, material excavated from trenches, tunnels, etc. And spoil piles must be kept at a minimal 1 meter, 3 feet from the excavation. All right. So protection against cave-ins. So providing my internet is working great. I've got a video coming up next here from WorkSafe BC. So let's see how this works.
I took a job working in basically golf course construction, something that I hadn't dealt with before. Everything that I had been doing was not related to really the construction industry. I moved into a role where I was capable of doing everything from, running a shovel to driving a dump truck, running an excavator, running a bulldozer. We started that morning running a ditch. Everything started off according to plan before coffee break, and came back from coffee break and went back to work, and within 10 minutes the accident occurred. We all basically noticed at the same time that there was the one side of the bank looked a little bit unsteady. So I was actually in the process of getting out of the trench. Without even seeing it, the whole wall of the trench just came down. Because I had my back turned, it basically got me on the back and the side, my right side. And the impact pushed me up against the other side of the trench and pinned me there. I actually started to go blind. I was asking my boss was above me. He had actually given me mouth to mouth to bring me out of it, and he started to fade away on me, and I couldn't figure out what was happening. I was asking him, why can't I see? Why can't I see? I was in induced coma for 10 days or 12 days. So I didn't even know what was going on really until a couple of weeks down the road. Meanwhile, everyone else, my family and everybody had been, through so much. The major injury was my pelvis. My pelvis was fractured in 6 different spots, and a couple of them were pretty serious, with bones breaking off and spinning around, and them having to go and basically retrieve them and put them back in their place. First time I remember seeing my dad, I woke up in CCU, critical care, and I thought, everything was okay, and all I was, I did, because of the numbness from the injury, everything, I didn't have a lot of pain. I just, when am I getting out of this place kind of thing? And my dad came and saw me, and he just basically broke down. Yeah, it was pretty tough on him, right? My fiance had kept a diary, and about 2 months down the road, I read through the diary, and it was the first 2 weeks that I was in the hospital. I couldn't even get through it because, just seeing what she had gone through, it was pretty tough. It's been quite a price. I mean, it's been 9 months. It's been a very long 9 months. I still have time to go. I'm still walking with a crutch, and sometimes to try my best to walk without any, but that all depends on how my body feels that day. And for someone like myself who 25 years old and athletic and everything, and then just one day everything's put on hold, no time to send an email message to let people know or make a couple phone calls, just split second, everything stops.
So I guess the questions you have to ask is what could they have done differently leading up to the incident? Did they handle the situation appropriately? And what other steps could they have taken? Videos like this, especially when you're starting to open up an excavation or trench, are great to show your workers, you know, if they're not watching this webinar, and then ask those questions to get some conversation going, because this gets people thinking about the real dangers of being in excavation. I've pipelined, I've done commercial construction, I've been in lots of trenches and lots of excavations. And when you do it enough, it just becomes something that you're not necessarily thinking about as a young worker. You know, I was 19 working in pipelines, and it was the last thing on my mind, right? Was a cave-in, even though the odd time one of the excavators operators would talk about it, right? So this is something to definitely bring up in those safety meetings and debrief everyone before moving into that excavation or trench. All right. So in accordance with section 262.1, protection against cave-ins of excavations, the employer contractor must ensure that protection against cave-ins or sliding material is installed where workers in a trench deeper than 1.2 meters. This is very important. It's in bold at the bottom for a reason. That a competent employee acting as a safety monitor must be used when digging a trench. So a competent person is an employee who possesses the knowledge, experience, and training to perform a specific duty. In this case, the employee may have the knowledge, training, experience with working on excavations and trenches. In particular, soil analysis would require a competent person to perform testing of soil. And in many cases, this ends up becoming a third-party agency that works in that type of engineering field, because it is very important to get the right test done. In Saskatchewan, there are 3 basic methods of protecting workers against trench cave-ins: cutback, shoring, and temporary protective structures. Sloping technique is used to employ a specific angle of incline to the sides of an excavation to protect against cave-ins. Cutting back the slope of trench walls is a way to protect against cave-ins, is basically what it is. The slope angle required may vary depending on the soil conditions, so a competent person must determine the correct slope angle for each situation. Temporary protective structures. A structure or device in an excavation, trench, tunnel, or excavated shaft that is designed by an engineer. The structure provides protection from cave-ins, collapse, and sliding or rolling material. Types of structures include shoring, trench boxes, trench shields, and similar structures. We're going to cover shoring and trench boxes. So shoring prevents movement of soil, underground utilities, roadways, and foundations. It's a process of bracing the walls of a trench in order to prevent collapse or falling earth into an excavation. Traditional wooden braces, hydraulic rams, or pneumatic rams can be used. An engineer is required to certify that a design of shoring is safe. Shoring for temporary structures must be made of number 1 structural grade spruce lumber. The OH&S regulations outline shoring procedures that must be followed. Those are within Regulation 262 and Table 17. And we'll show you a little bit of that coming up here. Dimensions for excavation and trench shoring is the title of that. Trench boxes. Instead of supporting the trench face, trench boxes primarily protect workers from cave-ins or similar situations. They act as a shield and are commonly used in open areas away from utilities, roadways, and foundations. Designed by an engineer, they protect workers from cave-ins, collapse, and sliding or rolling material. Most fatal cave-ins occur on small jobs of short duration. We kind of covered that earlier. Those are usually generally with service connections and excavations for drains and wells. Too often people think that these are not very hazardous and they skip the safeguarding process. So again, unless those walls are solid rock, never enter a trench deeper than 1.2 meters unless it's properly sloped, shored, or protected by a temporary protective structure. That comes up a few times because it's extremely important that it's followed. One way to ensure that a trench will not collapse is to slope walls. Where space and other requirements permit sloping, the angle of the slope depends on soil conditions. Cut the trench walls back at an angle of 1 to 1, so 45 degrees. That's 1 meter back for every 1 meter up. Walls should be sloped within 1 meter, 3 feet of the trench bottom. The Saskatchewan OH&S regulations identify 4 types of soil are categorized are most closely exhibiting the characteristics within section 257 E, F, G, and H. Type 1 soil is hard in consistency, very dense and compactive condition, can be penetrated, but only with difficulty by a small, sharp object. It has a dry appearance, no signs of water seepage, can be excavated only by mechanical equipment. Type 1 soil does not include previously excavated soils. Type 2 soil is very stiff in consistency, dense in compactive condition, and can be penetrated with moderate difficulty by small, sharp objects. It has low to medium natural moisture content and a damp appearance after it's excavated. It is difficult to excavate with hand tools. It has no signs of water seepage and does not include previously excavated soils. Both types of soil, type 1 and type 2, must be sloped within 1.2 meters, 4 feet of the bottom of the excavation or trench, with a slope angle not steeper than one horizontal to one vertical at 45 degrees measured from the horizontal. So that's, again, type 1 and type 2 soil. Type 3 soil is very stiff in consistency, compact in compactive condition, and can be penetrated with moderate ease by a small, sharp object. It is moderately difficult to excavate with hand tools and exhibits signs of surface cracking. It shows signs of localized water seepage or is previously excavated soil that does not exhibit any of the characteristics of type 4 soil. This type of soil must be sloped from the bottom of the excavation or trench with a slope at an angle not steeper than one horizontal to one vertical or 45 degrees measured from the horizontal. Type 4 soil is soil that has been either previously excavated or is undisturbed soil that has any of the following characteristics. It's very soft in consistency, loose to very loose in compactive condition, and is easy to excavate with hand tools. It's a cohesive soil that is sensitive and, on disturbance, is slightly reduced in internal strength and is dry and runs easily into a well-defined conical pile. It has a wet appearance and runs easily or flows and is granular soil below the water table unless the soil has been dewatered. This type of soil must be sloped from the bottom of the excavation or trench with a slope at an angle not steeper than 3 horizontal to 1 vertical or 19 degrees measured from the horizontal. This again is within section 262C. Where the soil is identified as consisting of more than one soil type, the soil will be classified as a soil type with the higher number. So, for clarification, if it was 2 and then you found out as well soil type 3, it would be classified completely across the board as a soil type 3. Although sloping can reduce the risk of cave-ins, the angle must be sufficient to prevent spoil not only from sliding back, but from exerting too much pressure on the trench wall. Sloping is commonly used with shoring or temporary protective structures, or trench boxes, to cut back any soil above the protection zone. It's also a good practice to cut a bench at the top of the shoring or trench when the depth of the excavation below the slope sides exceeds 1 meter, 3 feet. The support structure should extend 2 feet above the bottom of the slope sides to prevent any material from falling into the excavation. This is within regulation 262(1)C. So as you can see in the picture, how they cut the bench in from the top of where the shoring is, and that shoring extended above, right? So, and also this also can save material doing this bench cut above the trench, right? Because now if you have to go by regulations 2 feet above the bottom of the slope sides, you're saving material because you've had to dig that bench out as well. So it's also good for the pocketbook, I guess, this regulation. Where sloping is to be used above the temporary protective structure, trench box, the box portion of the cut should be first sloped 1-to-1 ratio. Then the box should be lowered into the trench. So here's that table 17 I was talking about earlier. Temporary protective structures such as metal shoring and trench boxes or cages must be manufactured to an accepted standard or designed by a professional engineer. Assembly, installation, use and maintenance, and dismantle of structures must be in accordance with the design. Wooden shoring shall be number 1 structural grade spruce or equivalent and installed as set out in table 17 of the OH&S regulations appendix. Temporary protective structures such as trench boxes are not usually intended to shore up or otherwise support trench walls. They're meant to protect workers in case of cave-ins. They are capable of supporting trench walls if the space between the box and the trench wall is backfilled. Protected structure should exceed at least 300 millimeters, so that's 1 foot, above the excavation. That's also located in Regulation 262(1)C. Trench boxes are normally placed in an excavated but unshored trench and used to protect personnel. Properly designed structure is capable of withstanding the maximum lateral load expected at a given depth in a particular soil condition. Trench boxes are commonly used in open areas. Trenches near utilities, streets, and buildings may require a shoring system. As mentioned earlier, trench boxes primarily protect workers from cave-ins in similar situations. They act as a shield and are commonly used in open areas away from utilities, roadways, and foundations. Designed by an engineer, they protect workers from cave-ins, collapse, and sliding or rolling material. Temporary structures used in an excavation, again, should be more than 3 meters deep, 1 foot above the excavation. As long as workers are in the trench, they should remain inside the box and leave only when the box is being moved. A ladder must be set up in the trench at all times. Excavation should be done so that the space between the trench box and the excavation is minimized. This may require some backfilling. 2 reasons for this are allowing closer access to the top of the box, limiting soil movements in case of a cave-in. Shoring is a system which shores up or supports a trench wall to prevent movement of soil, underground utilities, roadways, and foundations. Shoring should not be confused with trench boxes. Trench box provides worker safety, gives little to no support to the trench walls or existing structures such as foundations and manholes. The 2 types of shoring most commonly used are timber and hydraulic. Both consist of posts, wales, struts, and sheathing. So if we look at figure 15 and 16, these identify components for timber shoring and some typical. In figure 15, we have our posts, whalers, sheathing, and struts. And in figure 16, we have our post, whalers, closed sheathing, and struts. Right. So you can see as these pieces go together, again, your sheathing is actually up against the excavated area. Your whalers go across to help spread the load that's placed by the struts, or the cross braces that are pushing against each side of the trench wall. So this would be on both sides of the trench wall, as seen in some of the previous photos. And it's really important that A, they follow all regulations set out, but B, you want to make sure that they're placed not only very securely, but also in a manner that allows workers to move safely in between. The reason it's so important to make sure that these are secured is because workers will be working in that area. And the last thing you need is someone actually bumping one of the struts, right? And I hope, nobody decides to sit and eat their lunch in an excavation. Definitely don't use the struts or whalers to step up. That's why you have your ladders. They shouldn't be sat on, place material on, or anything, because they are holding some weight when required. Timber sheet supported with the help of timber posts. This basic type of temporary shoring used. So this is just a basic up close, so you get kind of a good idea on what it looks like and how it's laid out. So hydraulic shoring includes the use of prefabricated strut and whale systems manufactured of aluminum or steel. Strictly speaking, these may not operate hydraulically. Some are air operated or they're manually jacked. One major advantage of hydraulic shoring over some applications of timber shoring is safety during installation. Workers don't have to enter the trench to install the system. Installation can be done from the top of the trench. These are really handy. They're not cheap, but they are extremely handy. If you've ever had the chance to see them operate, they're amazing. Other advantages of most hydraulic systems is that they're light enough to be installed by one worker, are gauge related to ensure that even distribution of pressure along the trench line. They can have their trench faces preloaded to use soil's natural cohesion to prevent movement, and can be adapted easily to various trench depths and widths. Hydraulic shoring should be checked at least once per shift for leaking hoses and or cylinders, broken connections, bent faces, any damaged or defective part. Another form of shoring is pneumatic shoring, which is very similar to hydraulic shoring. The primary difference is that pneumatic shoring uses air pressure in place of hydraulic pressure. Disadvantages of using pneumatic shoring is that the air compressor must be, available on site. So I'll just give you a second to kind of take a look at how this is put together. Very similar to the last pictures. It's just your struts have been changed out for those pneumatic or hydraulic jacks. There's different plates that go with it, right? Like the sole plate you can see here. But it's very, very similar. It's just all prefabricated. But most hydraulic systems are light enough to be installed by one worker, gauge related to ensure the even distribution of pressure along the trench line, easily adapted to suit various trench depths and widths. Whenever possible, shoring should be installed as excavation proceeds. If there's a delay between the digging and shoring, no one must be allowed to enter the unprotected trench. All shoring should be installed from the top down and removed from the bottom up. Whether protected by sloping boxes, shoring, where workers are required to enter and work in a trench, there must be a safe means of entry and exit within close proximity. In accordance with legislation, section 2636, entry and exit must be within 8 meters, 26 feet of the worker. Entries and exits include ladders, stairways, sloped ramps. When using a ladder to prevent slipping, the ladder should be placed within shored area and tied off. Place ladders within the area protected by the shoring or trench box. Securely tied off the top, extended above the shoring box by at least 1 meter, 3 feet, and inspected regularly for damage. For more information on inspecting a ladder, get in contact with an advisor to talk more about our ladder demonstration, to which we can do over all our mediums, so Zoom or Teams or anything like that. We can conduct these demonstrations. All right. So in Regulation 2636AB, protection against cave-ins of trenches, safe entries and exits from a trench are very important. Ladders, stairways, or ramps should be placed no further than 8 meters from a worker in a trench deeper than 1.2 meters. Anyone climbing up or down must face the ladder and maintain 3-point contact. Maintaining 3-point contact means hands must be free for climbing. Tools and materials should not be carried up or down ladders. Pumps, small compactors, and other equipment should be lifted and lowered by methods that prevent injury from overexertion and falling objects. This is why I said it's great to have a telehandler on site when it's available. If you have compactors to bring in the bottom of the trench to use, your base compactor or anything, you can simply boom out, put your outriggers down, boom out with the telehandler. Using a nice long sling, you can actually drop it safely into the trench. When it comes to inspection, remember that it's everybody's responsibility. Whether the protective system used should be inspected regularly. Check hydraulic shoring for leaks in hoses and cylinders, bent bases, broken or cracked nipples, or other damaged or defective parts. Make sure that you're checking timber shoring prior to the installation, like check the actual timber itself too. Discard damaged or defective lumber. After installation, inspect whalers for signs of crushing. Crushed indicates structural inadequacy and calls for more struts. All right. And you can see in this picture how they've secured this with some strapping, like a 1x4 or 1x6, where it's nailed to your whalers from your struts. That's a great way, instead of just, if you're familiar with toe nailing, where you're just nailing through the sides of it. That's a much better way for doing it. I've seen people that use brackets. They use 2 L brackets on the side and then 1 flat bracket on top to make sure it's secure properly and it's not going to move anywhere. These boxes should be inspected for structural damage, cracks and welds, and other defects. During use, check the box regularly and often to make sure that it is not shifting or settling much more on one side than the other. If it is, workers must leave the trench and ask the supervisor to check stability. Check ground surfaces for tension cracks, which may have developed parallel to the trench at a distance 1/2 to 3/4 of the trench depth. If cracks are detected, alert the crew and check all protective systems carefully. So you can see in that picture where those tension cracks are, right? So they would be running parallel to your trench box or shoring. All right, so just a quick recap on protection against cave-ins. Unless proper sloping and temporary structures are in place, no one should enter an unprotected trench deeper than 1.2 meters. Cutback should be angled at 45 degrees, ratio 1:1. Type 4 soil is the least stable soil, and it is easy to excavate with hand tools and may previously been excavated. And sloping is the cutback of the trench wall to protect against cave-ins. And keep in mind, type 4 soil is the soil that requires a different cutback. So, all right, so other hazards and safeguards. Working around excavation and trenching also requires consideration of the following: PPE, personal protective equipment, my apologies, utilities around and overhead, materials handling and housekeeping, heavy equipment, traffic control, confined spaces. Injuries and deaths have resulted in the failure to acknowledge or recognize the importance behind pre-planning to ensure these major areas are accounted for. We'll be focusing on PPE and utilities, underground and overhead today. That's what we're going to be concentrating on out of all of these. Wearing high visibility safety apparel, so vests, protects workers who are exposed to the risk of injury from moving equipment or environmental conditions so they don't blend in with the surroundings. And it's extremely easy when everybody's wearing brown Carhartts and Carhartt long sleeves and toques and stuff like that. When you're on a job, it's very easy for them to blend in. Eye protection is strongly recommended to prevent injuries from construction operations such as chipping and drilling, and site conditions such as dust. OH&S Regulation 93, eye and face protectors. Personnel exposed for long periods to noisy equipment should be wearing hearing protection. This is found in OH&S Regulation Section 99, exposure to noise. Work in confined space, such as manholes and valve chambers, may require respiratory protection against hazardous atmospheres. This is located within Section 88, 89, and 90. Saskatchewan legislation requires employer and contractors to inform workers where, when, and why they're required to use PPE. Provide workers with appropriate and properly fitted PPE at no cost. This is excluding specialized footwear. Train workers in the use, care, and maintenance and limitations of their personal protective equipment. Workers provided with personal protective equipment must use proper fitting PPE appropriate to the job. Inspect, test PPE before each use. Care for and maintain PPE and report effective or malfunctioning personal protective equipment. So let's go over a couple of things before you start digging. Prior to starting a project, you must first notify SAS First services such as gas, electrical, telephone, and water lines. Those must be located by the utility provider before excavation begins. Call SAS First provides free services for anyone planning to dig or excavate. They provide underground facility screening and locate by markings underground services with label, stakes, flags, or paint. This method is used to indicate the center line of an underground service and provide a diagram of locate information. Line locates requests can be submitted 24 hours a day, 7 days a week. Requests for line locates must be made a minimum of 2 full working days, excluding day request is submitted prior to the beginning of the project. When making the call, be prepared to provide city, town, or project location, your addresses, 2 intersecting street names for the urban locations, the type of work being done, and the start date. You'll receive a notification when lines are marked and it's safe to start your project. Keep in mind that line locates are only valid for 10 business days. If the project is delayed or past the 10-day period, call SAS First again to have the line marked one more time. In some cases, the lines must be supported. In this case, if the contract does not specify the method of support, you must contact the utility provider for the requirements. After being located and marked by the utility provider, services should be exposed first by hand digging, then by excavating equipment. Procedures are outlined in OH&S regulations under Section 259, locating underground pipelines. So this is a short video. This happened in Saskatoon. It was hitting an underground cable.
On August 28th, 2017, the city was doing some work at this intersection here in Taylor and Arlington, installing a right-hand turn lane. I received a call that the contractor had hit a power line while doing hydro excavation activities. The first thing that goes through your head, obviously, when that happens, is you hope that everybody was okay and that nobody was hurt. You do think about the impacts that could have had to their friends and family. The report was when they made contact with the utility, some fire did come out of the hole, so that's obviously scary. Once you learn that everybody is okay, you start to think about the next sort of impacts at that point. So work with the contractor, work with everybody to get power back on and make sure that everybody's safe. So in this case, pressures during hydro excavation operations were too high for this type of utility, and as well as the sweeping motion of the hydrovac wand itself weren't correct for this type of operation, as well as the access hole wasn't large enough to even accommodate a proper sweeping motion.
A lot of time, especially older cable, the outside jacket is buried underground for a long time. Like on this cable, probably over 30 years. So they are really soft and they don't able to handle as much pressure as the new cable is.
We're not here to assign blame. We're here to learn and to try and prevent these incidents from occurring in the future. I think there would have been, in the area of 1,000 to 2,000 people that may have been impacted. A couple primary care facilities. There's some retirement homes in the area, and there is an ambulance dispatch center around here. It certainly impacts the traffic, and if there was an ambulance that needed to go out at that time, I think that would have been a huge impact to them. I really hope that, when you're out doing your job, that safety is the primary concern. If you don't know something, it's okay to stop and ask. These utility owners know details about that specific utility that you may not. If a company or contractor did damage the line, then they would often incur the direct cost for repairing the line. And there's oftentimes indirect costs as well. We don't want anybody to get hurt or worse, and working around these high-risk utilities is dangerous, and we want to make sure that everybody gets home at the end of the day.
In Saskatchewan, maximum fines for incidents causing serious injury or death are $500,000 for an individual and $1.5 million for a corporation, the highest in Canada.
All right. So line break or hit could lead to lengthy service outages, equipment damages, costs to respond and repair lines to restore services affected. These expenses alone can be costly, adding up to thousands of dollars, could lead to fines and legal action. Worst case, a line could break or hit could lead to an injury or death. So ensure that cutting telephone lines can create a serious problem if emergency calls for police, fire, ambulance are required. In the event of a gas line contact, call the appropriate utility company immediately. More often than none, almost, I would say all of them, but I can't be quite certain, have a 24 emergency line. So use that emergency line if required. So when you have a line break, it's important to make sure that you evacuate the area. People in the immediate area should be told to evacuate. Where service to a building or home has been struck, people inside should be advised to leave doors and windows open, shut off appliances, furnaces, and other sources of ignition. Vacate the premises until the gas company declares it safe to return. Construction personnel should take 2 precautions. Leave the trench immediately. Gas can collect in those low trenches, and put out smoking material and shut off other sources of ignition such as engines and equipment. When it comes to overhead power lines, equipment such as excavators or backhoes must not be within 3 meters of an overhead power line unless a signal person is stationed to warn the operator when any part of the machine, boom, or load approaches a minimum distance specified in the regulations. Sask Power, Sask Energy, or city utilities must be notified prior to working on an overhead power line, or Sask first calls must be contacted and notified prior to working on an overhead power line. If equipment touches a high voltage line, the operator should take the following precautions. Stay on the machine. Don't touch equipment and the ground at the same time. Touching anything in contact with the ground could be fatal. Keep others away. Warn them not to touch the load lines, boom, bucket, or any part of the equipment. Should you run into an instance where the equipment touches a power line, call the local utility to shut off the power immediately. If possible, break contact by moving the machine clear of the wires. Otherwise, do not move the machine until the utility shuts down the line and confirms the power is off. If an emergency such as fire forces you to leave the machine, jump clear. Never step down. If part of your body contacts the ground while another part touches the machine, current will travel through you. Jump with the feet together and shuffle or hop away in small steps. Don't take big steps. With voltage differential across the ground, one foot might be in higher voltage area than the other. The difference can literally kill you. Special precautions are required for casualties in contact with live power lines. Never touch the casualty or anything in contact with the casualty. If possible, break contact. Use a dry board, rubber hose, or dry polypropylene rope to move either the casualty or the line. An object can sometimes be thrown to separate the casualty from the wire. Call emergency services. In most cases, ambulance, fire department, and utility. Provide first aid once the casualty is free of contact. If the casualty is not breathing, begin artificial respiration immediately, or CPR. Apply cold water to burns and cover with clean dressing. The real deal is that you should have, and by law, someone with first aid training that knows all these steps. So far for this section, we've reviewed PPE, utility locates, underground and overhead utilities, and how to respond to emergency situations. Use appropriate and properly fitting personal protective equipment. Notify SAS first before digging. If a leak is identified or suspected, contact the utility company immediately. When working around overhead power lines, equipment must be notified equipment must not be within 3 meters. In the event of contact an overhead power line, stay calm. You may be required to contact utility services to disconnect. In highly hazardous situations, call 911. All right, let me just stop the screen share here. Perfect. Okay, so now that that has all been handled, we have some questions that were brought to the advising staff prior here. So I wanted to just bring these up to our panel here and talk about them a little more. So one of the questions is, and this is actually a good one because it wasn't covered at all in the presentation, is, Joanne, I'll send this one your way. Can an excavation and a trench be on the same site as part of the exact same dig?
Yeah, it can. Oftentimes you'll find that you actually have an excavation, whether it be commercial or for a house. And what's going to happen is they're actually going to have a trench in the bottom of that excavation for maybe some underground plumbing, wiring, and so forth. And you want to make sure that you actually use proper precautions, again, against cave-ins and trench boxes as well. Going to be handy in this situation, but you'll also find that, like I said, they're going to be used together.
Awesome. Yeah, absolutely. And this is something that you see quite a bit in commercial construction, but you see it a lot of times, every once in a while you see it in residential. I didn't have a whole lot of residential experience, but I've seen it a lot in commercial. Karen, I'm going to fly this one your way. Do you have to report cave-ins for both trenches and excavations? I'm assuming
Yes.
they mean to like the division. I'm thinking like reporting.
Reporting to OH&S. Can you hear me?
Yeah, absolutely.
Okay.
Yeah. Sorry, I muted at the same time you were talking.
Sorry. Yes, you have to report the collapse under Section 9 of the regulations, which states that an employer, contractor, or owner shall give notice to the division as soon as possible. 9(1)(a)(2), all or any part of an excavated shaft, tunnel, caisson, cofferdam, trench, or excavation needs to be reported. Just to kind of go through, because we only kind of talked about excavations and trenching in the presentation, we'll kind of go through a couple more definitions here. So an excavated shaft is basically explained as a vertical tunnel. Aside from the fact that the entrance and exit is the same unless it links with a tunnel underground. A tunnel is an underground passageway dug through the surrounding rock or soil, and that is fully enclosed except for the entrance and exit on either side. A caisson is a watertight workspace with a personal access point and air supply that, once the water is pumped out, will allow underwater work for bridges and ships. And then a cofferdam is an enclosure built within or in pairs across a body of water to allow the enclosed area to be pumped out. The pumping of the water creates a dry working environment so that work can be carried out safely.
Awesome. Yeah, that's important to know too, because a lot of times, like, you know, especially as construction companies, they like it's only you know, only working with excavations and trenching. So then they kind of slough off the other stuff, but you never know where your career might take you. And it's important that, you know, once you have this knowledge of Section 9, is to know what all these other things are, because I don't know how many times I've read through that, like even just giving orientations in my past career before safety. And I had no idea what a cofferdam was. I just thought it was just a different style of like dam from bank to bank on a river. And I had no idea. Then you look it up and you're like, man, that it's not sketchy, but like when you look at like a enclosed area in a lake that's completely dry and people are working with, you know, 15 feet of water surrounding them, it's no wonder it's in here, right? So here's another one. This is actually a good one. It's not covered. I'll throw this one to you, Kieran. Is there a maximum size a spoil pile can be? So I'm assuming height and, you know, volume wise, I guess. What I'm assuming they mean.
Yeah, so that's an interesting one because there's no specific legislation that states it can only be X amount of feet high. One of the things it does state, though, is that it has to be at a 45-degree angle or 1-to-1, like we saw in many of the diagrams in that presentation there. So yeah, if we're looking at it and it's that 1 meter away from the excavation, it's technically legal, but there's, again, looking at it in a practical sense, you have to ensure that it is in fact safe. So if it's reasonably practicable to have it 5 meters back and not have it higher than 30 feet or something along those lines, setting up something for your own site, keeping in mind power lines, space, and all the little things that kind of go into a day-to-day operation, you have to use it and look at your planning phase. So if your plans allow for a certain amount of spoil pile in different areas, and you can allocate that space, use it, and don't have that surcharge near the side of the excavations.
Yeah, absolutely. Especially when you're working with small sites. Like I've been on some real crushed in sites where you're like, oh, we need room for the spoil pile, we need the trailer, we need the C panels, we need the boneyard where all the, you know, all the steel and everything, rebar is going to get shucked out. And so all of a sudden you're like, where are we going to put all this massive amount of dirt? Right. So yeah, absolutely. It's got to be definitely thought out in the planning stage. Here's a good one, actually. Yeah, this let's see. So I'll jump over to Joanne. This is actually, I think, mentioned twice in the presentation. Lumber grade. Lumber grade has been mentioned specifically with wooden shoring. What is #1 structural grade lumber, and how can you tell that it is indeed #1 grade?
Okay, so one of the first things you want to do with the lumber is actually take a look at the stamp. The lumber should be stamped according to the manufacturer. It's going to have the grade agency, like who graded it, the mill, where it was milled, what species it is, moisture content, and it will actually have an assigned grade at that time. So when the mills are actually giving that stamp, or the manufacturer, #1 is going to have the least number of defects in it. There might be a few knots, but they have to be a certain size. That would be very minimal. And they have to be sound and firm and tight and well spaced. So it's got to be good quality, very little defect. And they do have a guideline on how to grade their lumber when they go through the mills and manufacturing. You're muted.
Yeah, I must have been unmuted in the beginning. A lot of young workers that I've worked with, you know, I had one actually once upon a time that was cutting a piece of lumber. You know, I cut it for me 6 feet or whatever. Like, oh, I cut through the stamp. Is that going to be okay? And right? Because nobody really looks at that. They have no idea, right? So we got a few minutes left. This is a quick one. We did go over this, but it's good to touch on it again. Kara, when using a ladder in a trench, do you have to follow the same ladder regulations as if it was being used in a building?
Yes, the regulations aren't specific about where you use a ladder, just if you are using a ladder. So if you are using a ladder, regardless of where you are using it, regulations still need to be followed for the type of ladder that you're using. So portable ladders are covered in section 253, as any ladder that is not fixed in place, including step ladders. In the entirety of section 253, portable ladders, and 254, use of portable ladders. It doesn't make, like I said, mention of rules changing depending on where the ladder is in use, but rather if the ladder is in use.
Perfect. So just go to those regulations. Everything is the same, 100%. Doesn't matter where it is. It's just that you're using a ladder.
Exactly.
We got time. We might go 1 minute over, but we only have one more question left. So this one's for Kieran. So this is actually good. How do you determine the soil type? Is there a test you can perform, like aside from just staring at it?
There are. Just as the legislation states, there's kind of some general ways to figure out what kind of soil type you have. A sharp object is probably a spade. So if you can't dig with a spade, you're looking at type 1, type 2, type 3, again, a little bit softer, and type 4 is like loose dirt. So those are some good methods of testing, but that's not something you do before you dig potentially. So that could be determining just in the planning phase what kind of budget you have to allocate for actual testing. So a really good way, or the best practice way to get testing, is to have someone who is trained, like a civil engineer, technology professional, that knows how to do that test and perform it with a slide hammer. So they have different ways of measuring those tests. There's different standards. The common one's a slide hammer, and they slam it into the ground, and a certain number of blows determines what type of soil it is. And that's the short version of that answer. Muted again.
Man, right at the end, of course, right? There is a lot that goes into that kind of stuff. And again, when in doubt, consult an engineering firm or someone that does that third-party testing to just be sure. Asking the neighbor that built a building right next door probably isn't the best option, right? So, and dirt doesn't talk back, so you can't just ask. All right, so we're at 1 o'clock. I just wanted to thank everyone for watching. Thanks to the panel for being here for us. Be sure to tune in next week for our toolbox talk on developing procedures. And then our next Wednesday webinar, or Webinar Wednesday, however you want to say it. We have a special executive series with special guests John Desjardins and President and CEO of the Saskatchewan Construction Association, Mark Cooper. They're going to be speaking on diversity. So I hope everyone learned a lot, and stay safe.